In this lesson, we're going to dilate segments, lines, and rays, and then in class we're going to dilate circles, and we're going to see what relationships maintain and what happens when we dilate different segments from different centers of dilation. So here we have PQ, and we want to dilate with a scale factor of 2 from center 0. Now, at home, when you're watching this, you can use a straight edge and a compass. Since I can't do that as well on here, I'm just going to have to sketch it in. So my lines will not be perfectly straight. My arc marks won't be made by a compass, but you will get the general idea of what you do. If we're going to dilate from O, that means I want to take my straight edge and extend a line from O through P and from O through Q. And again, your lines will be straighter than mine. And then you would take your compass, center at O, and measure out to P. And since we're dilating by a factor of 2, we're going to double line OP. So I measure this, so you should have a little arc mark there. And then I come out to P, center at P, and make the same arc mark. And that's going to be P prime. We do the same thing with Q. We measure segment OQ, and then we come out here and we mark off the same distance with our compass, and that's Q prime. So if I were to connect P prime and Q prime, that's going to give me a line segment. And again, you do this with a straight edge and your compass, and it's going to look much better than this. So let's take a look at that. Is the image still a segment? Well, see for yourself. Yep, I go from P prime to Q prime. So yes, P prime, Q prime is a segment. Nothing changed there. What's the relationship between PQ and its image after the dilation? Well, we should pick out two things. First of all, if you look, the two lines are going to be parallel. So PQ is going to be parallel to P prime, Q prime. And then what do you think about their lengths? If you take a look and if you measure with a compass, if I scaled it by a factor of 2, that means my image, P prime, Q prime, is going to be double my original. So those are the two things you should pick out by dilating a segment. Alright, we're going to do the same thing, only this time we're dilating a line, which means I have 2 points on the line. I'm going to dilate from a center of O, and my scale factor is 2 again. So the process is the same. Again, you use the straight edge, you draw segment OP and OQ and extend beyond, and then we take our compass, center at 0, we mark off that length, and we mark off the same length. We mark off the length to OQ, and we mark it off again. So, but you should see, this time instead of drawing a segment, I'm going to draw a line. And that line goes through P prime and Q prime. So, is the image still a line? Yep, we didn't do anything to change that, so yes, it is still a line. And then the relationship of PQ and its image after the dilation. Well, again, they're going to be parallel, and the distance between P and Q is going to be half the distance of P prime, Q prime. So the line segments have that same relationship again. So we can say line PQ is parallel to line P prime, Q prime. And segment, we'll write it this way, segment P prime, Q prime is still double segment PQ. So now we're changing things up just a little bit. Here we have a single line, and the center is going to be at R. So I'm going to dilate from R, and I'm going to dilate P and the segment PQ by a factor of 3. So the process is the same. I start at R, and I'm going to take a straight edge, and I'm going to extend a segment out. Let's see if I can do this fairly straight. Okay. And then I need to mark off the length RP and mark it off 2 more times to scale it by a factor of 3. So if I put an arc mark at P, again, you're using a compass, center at R, measuring out to P, and then you're going to come over, and I just have to kind of eyeball it and mark off that same distance 3 times. This is P prime. We do the same thing with O. We mark the, or Q. We mark the distance between R and Q with our compass. I'm going to make that a different color, make that blue. And then we come out and mark off that same distance. So this is Q prime. How much longer is P prime Q prime than PQ? Well, here's the distance P prime Q prime. Let me see if I can shade that in. Here's the distance PQ. If you measured and did things accurately, you should see that P prime Q prime is going to be 3 times PQ, which is what you would expect if we're scaling by a factor of 3. Now, what do you notice about line PQ versus line P prime Q prime? Well, if you look at it, they're all on the same line. So, dilating a line when the center is on the line doesn't change anything. It's the same line. So they are all collinear. We can write there. We can write they share the same line, or they are collinear. So just to summarize the first part here, and then the last part we're going to do in class because it's a little bit trickier. The dilation of a line segment is longer or shorter in the ratio given by the scale factor. So if I dilate a line segment by a scale factor of 2, then my new line is going to be twice as big as the old. A dilation takes a line not passing through the center to a parallel line. So if the center is not on the line itself, then a dilation of it is going to create a parallel line. However, if the dilation is on the center, or if the center is on the line, then you're just going to get the same line again when you dilate it. So that's what happens when you dilate a segment and a line, and also a ray, really. We'll talk about that. What we'll do in class is look at what happens when we dilate circles, and then we'll do some practice.